Now let's solve invert binary tree. In this problem, we're given the root of a binary tree and we need to invert the tree and return its root. So if you notice in example 1, we have this original tree. After we perform a certain code, or after we invert the tree, we're going to get the 7, which was initially on the right, is now on the left side. And similarly, their children have also been flipped. So the 6 is now where the 9 is, and the 1 is where the 3 is. So if you notice the final product, at each level we swapped left with right. So 7 is now here, and the 2 is now here. So at each level we swap the left with the right. So at this level we swap the 2 with the 7, and so now 7 is here and 2 is here. And the 6 and 9, where the 6 used to be on the left of 7 and 9 used to be on the right of 7, we also flipped it. So now 9 is to the left of 7 and 6 is to the right of 7. Similarly, with the children of 2, we swapped the left with the right children. So we're going to solve this recursively. First and foremost, we're going to check if we reached a null node. So if root is equal to null, then what do? We just return null. We don't need to swap anything. We don't need to swap anything and the value remains null. We just leave it there on the tree basically. Otherwise, what we're going to do is we're going to create a tree node called temp for temporary, which is going to be equal to root.write because we want to save root.write because I'm going to overwrite it. So we saved its contents into a tree node called temp. Now we're going to swap them. So root.write is now going to be equal to root.left. So now we have a tree where to the left of 4 is 2, and to the left of 2 is 1, 3, and also to the right of 4 is 2, 1, and 3. And then what we need to do is we need to update root.left to be equal to temp. And then, well, we need to return root at the end, but before we do that, we need to do this for the entire tree. And to do that, we're going to use recursion and call our function to do it for root.left. So invert the tree on the left branch, swap the left children with the right children, and also we need to do this on the right branch. So root.write, and then finally we return root. So let's submit our code and see if it works. And so yeah, that was the invert binary tree problem. Let's go through a quick example. So first and foremost, is 4 null? No, it's not. So in a variable called temp, store the contents of root.write, which is this entire branch. Basically, it's the 7, but the 7 is pointing to 6 and 9. That's what the tree node is. So then root.write is now going to be equal to root.left. Root.left is this branch. So now our tree is pointing to this branch on the left side and on the right side. But we need to change this left side to be what the right side was. So we make root.left is equal to temp. So now we have 4 at the top, 7 here, 2 here. And the children of 7 have not been swapped yet. So to the left of 7, it's still 6 currently. And to the right of 7, it's still 9. And similarly for 2 and its children. That's why we call invert tree root.left. So after we get to this level, we're going to do the same thing for the left children of 7 and the right children of 7. And we're going to do the same thing for the right children of 2 and the left children of 2. So I hope you found that video helpful, and thanks for watching.